this series on arrays and pointers. I'll be discussing a few topics on both of these, and for today we'll start with arrays. So what is an array? An array is a data structure which contains data items of the same type. So if you have an integer array, let's call it integer array 1, and let's say it has 10 integers. So basically an array is a set of data items of the same type. Here we have type integer, and the important thing to note in an array is that those items are located at consecutive locations in the memory. So in this case, your array location addresses will be one after the other. For example, if this is at address 1000, then the next location, which would be 1000 plus how much ever is required to store an integer, 1000 plus size of an integer, would be the address of this, and the address of this location would be again this one plus the size of an integer. So it would be located at consecutive locations in memory. That is important aspect of an array. So two things: arrays are data items of the same type, and they are located in consecutive locations in the memory. How are arrays accessed? So when you have an array of 100 elements, and when you try to write to the 50th element, let's say you'll write value 4, what internally happens inside the compiler? So in this case, when the compiler compiles this program, it knows the address of array 1, which is actually called the base address. So base address is where the array starts in memory. So on compilation, the base address of array 1 is what the compiler knows. So let's say that is something like 1000, and since the compiler knows that it is an array and data items are located in nearby memory locations, rather consecutive memory locations, all it needs is the first memory address and the number of which element you're going to access. So in this case, since you're going to access the 50th location, it would be 1000 plus 50 times the size of an integer. So in this case, it would be 1000 times 1000 plus 50 times 4. The size of an integer is 4, and it would be 1200. So that way it would calculate the L value of this, and it would go and write 4 into that. Note, however, that this L value is computed at compile time itself, because all the compiler needs to know is the base address of the array. Base address as in the address of the first location. In this case, for example, it is 1000, and it also knows that you are trying to access location 50. So you add 50 times the size of an integer. So you would need to go that many integers forward to find out the address of the memory location, and once you have found out the location, you write 4 into it. So that is how arrays are accessed in memory. The next topic I want to talk about in this is how pointers are accessed in memory. So when you have a pointer declared like this is actually a definition, not a declaration, I'm sorry. So when you have a pointer defined like this, and when you try to access the third element of the pointer, what internally happens? Let's study about that now. So what does this definition say? First thing it says is that P is a pointer and it points to a character. P is not a character in itself, it has the address of a character. So this would be where ABCD is stored. Let's call that address 9000, and we have character pointer P, and P would contain the address of A, which is 9000 in this case. So P is an indirect reference to the first object of the string. So what the compiler does is it dereferences P, it finds out what is the value located at the address pointed by P, and then to this address 9000 it adds 3 times the size of a character, because again this is an array, and arrays are located in consecutive locations, and also you have 3 items here. So in this case it would be 9003. So note that this is a 2-level lookup process. So the first thing is that it tries to get the base address, and to the base address it adds the size of character times the number of locations it has to skip. Whereas when you declare something like char P is ABCDE, your P directly contains the address of A. So in this case your P would be 9000 directly. I mean, you don't need to dereference the value at P to get 9000 in itself. So P would be directly containing the address of the first element. So those are the 2 distinctions between array and pointer accesses, and thanks for watching.